heating effect of current. See, we have a conductor. This is a conductor. This conductor, it has got a resistance. Conductor is nothing but a resistance. When end to end, when a EMF source, that is a battery, EMF source is connected across the battery. This is positive side, this is negative side. It means a potential difference is created because this is positive side, this is negative side. A potential difference is developed across the ends of the conductor because of difference in potential. This is higher potential, this is lower potential. From higher potential, lower potential, the current starts flowing. When the current is flowing, it heats the conductor. That is resistance inside the conductor. It is heating. This effect is known as Joules heating effect of current in the conductor. That is, we can summarize, heating effect of current is nothing but when a potential difference, see potential, now we will draw this circuit like this. This we will replace as a simple resistance. Simple resistance. This is ends of the conductor. When EMF source, this is the EMF source, that is a battery is connected across this, EMF source is connected across this. The current will flow from a positive terminal to a negative terminal. This is the resistance. This is the potential difference developed across this conductor. See, this is the simplified diagram of this one. So, what is the I? I is where I is equal to, this is the end A and B of the conductor. That is nothing but a resistance. So, AB is equal to conductor of resistance R. AB of resistance R, and V. What is V? V is equal to potential difference developed by whom? When we are applying the source EMF source, it will create a potential difference between this and this side positive, this is negative. A potential difference is created across the conductor. So, potential applied across the ends of the conductor developed due to battery, that is battery of EMF E, and because of the potential difference is created, current starts flowing from here to here. I is equal to current flowing due to potential difference across AB. So, the current starts flowing where I is the current flowing in the circuit. For how much time it is flowing? T for time. T is equal to time for which the current flowing. Current is flowing. It means, see, because of this EMF source, so we can write EMF source is equal to source of EMF. Source of EMF. That is, these only responsible for creating potential difference and hence the flow of current through the conductor, that is the resistance. So, E is equal to source of the EMF. So, when the current is flowing through a conductor, when the current is flowing through a resistor, heat is produced, that is heat is produced. It produces heat. Heat is produced in the conductor. It means it is a type of energy, heat energy. So, how the amount of heat produced, when current flows in the conductor of resistance R in the given time, that is amount of heat produced due to I flowing due to I in the circuit. Amount of heat is flowing in the circuit, that is through the heat is produced in the resistor or the circuit of resistance R is given by heat energy. See, heat is nothing but energy. So we can denote it as H. That is H is equal to I square R into T. I square R into T in Joule. Why we call it as Joule? Because heat is energy. The unit of energy is equal to Joule, and 1 Joule. Now sometimes in the calculations we use in the calories. So 1 calorie is equal to 4.2 Joule. That is 1 Joule is equal to 1 by 4.2 calories. So this we can write is equal to I square R T, where T is equal to time for which how much time the current is flowing in the conductor. I square RT divided by 4.2 in calories. The heat or unit of heat is in either calorie or joule. Always remember the unit conversion is very, very important. This equation, that is H is equal to this equation is known as Joules' law of heating. This is known as Joules' law of heating. Now let us define some terms used in an electrical circuit. That is, we are going to define power, energy, etc., etc. What is power? A rate at which electric work is done by a source EMF. See, suppose we have here a resistance that is external. This resistance is nothing but an external load. It may be a fan, it may be a bulb, which is driven by the battery. That is source of EMF. This is source of EMF. It develops a potential difference across this one, and the current flows like this. So this is positive N, this is negative N. So current nothing but the rate at which the electrical work is done by the source of EMF in maintaining electric current in the circuit. That is called power of the circuit. That is rate of work. Rate of work means work done in a given time. That is power to work done in a given time. That is rate of work done is called power. So we know I is equal to current in the circuit, current in the circuit, I and E is equal to source of, this is equal to EMF. That is this is the source which drives the current through this resistance. That is source of resistance. It moves from this end to that end. So now as it is, we have seen in electrostatic, that is potential. V is equal to potential is equal to work done in a given time. This work done by a charge. This we have studied in the current, we studied in the previous one, that is electrostatic. That is, I is the current flowing, V is the potential maintained between ends of the conductor, AB is the resistance. This we term it, AB is the resistance. A and B is the, AB is the resistance, and epsilon naught is the source EMF. The total, what is the total charge flowing? See, we know charge, current is given by charge in a particular time, or charge is equal to I into T. It means charge has to, if charge is flowing, if the current is flowing from here to here this way, then charge is flowing. Charge is flowing in total, therefore we can write total charge flowing in a given time t. See, total time is equal to what is it? Charge from this expression, charge is equal to current into time, that is equal to current into time. This is charge, or we can write charge flowing is equal to I into t, where how much time is flowing. The total charge flowing from A to B of the conductor in time t is equal to this much. So V is equal to, what is the potential difference? Already potential difference, V is equal to, potential difference is equal to work done per charge, work done per charge. V is equal to W, or now we have to find out rate at which work done. This is the expression for power. So power we denote it by P is equal to work done. Here work done, it means work done is equal to potential difference into charge, potential difference into charge. So potential difference, power is equal to work done, and work done is equal to V by Q into power work done by time into time. See, we know Q by T. What is Q by T? Charge flowing in a given time is equal to current. So power can be written as V potential difference into I. Therefore, power is equal to potential difference between the ends of the conductor, this V, not ends of the conductor, and to I. As we know, V is equal to, potential difference is equal to I into R. I is equal to V by R. We can write, and V is equal to, since V is equal to IR, so this becomes IR into I is equal to I square R. This is power can be expressed this way also, replacing I by VR, so this is also I is equal to V by R is equal to V square by R. This is also another expression for power. Now let us discuss the unit of power. What is the SI unit of power? See, already we have seen work done, power is equal to rate of means time, rate of work done. See, work done is equal to the amount of work done is converted into energy. It means the unit of these two is in Joule, because it is by work energy theorem, how much work is done, equal amount of energy is converted. It means the unit is in Joule. So it means we can say power. So what is equal to power also? Power, work done by time, that is V charge. Work done is equal to V into Q. Work done, because work done by charge is equal to potential. It means work done is equal to V into Q, and time is equal to T. T is equal to T. So nothing but work done in by Q. So Q by T, what is Q by T? I is equal to charge flowing in a given time. So is equal to V into I. This is the expression for time. That is voltage into current for power. Voltage into power, how we can write? Therefore, unit of power. Unit of power is equal to, can be written as voltage means volt into ampere. This is one expression one. Another way we can write power is equal to, this is one, unit of power is equal to this one first. And power also, as we have written, power is equal to work done by time. Work done by time, that is work done by time is equal to energy by time. So unit of energy, what is the unit of energy? Is in joule. Joule divided by second. In SI unit, it is called watt. That means unit of power, we can write volt into ampere. Otherwise also joule, that is small g, joule per second, which we call it as a watt. This is one and this is another. So we can go for one more, this one more interest. And for conversion, since it is in, this is for energy. Energy is, that is conversion between joule and calories. See, 1 calorie is equal to 4.2 joule, by which we can convert joules into calories. Sometimes the numericals it may be given in joules, we may be asked to work in calories. So now 1 horsepower is equal to 746 watt, and 1 megawatt is equal to 10 to the power 6 watt. One more time, 1 megawatt, and 1 kilowatt. 1 kilowatt is equal to 1000 watt is equal to 10 to the power 3 watt. This will be handy for using for doing the numerical. So the unit of power is equal to volt ampere or joules per second or watt. Now let us discuss another term, that is electrical energy. Earlier we have defined about the power and its SI unit. Electrical energy. What is electrical energy? We have a circuit having a resistance. This is, we can call, this is a conductor. This is the source of EMF. And it maintains, this source of EMF maintains a potential difference V, and this is the resistance. This is the current flowing in the circuit. See, when current is flowing, heat is produced, heat is dissipated, comes out of the resistor in the form of heat energy, and that heat energy, by work energy theorem, how much work is done by this battery to move the charge from here to here is converted into energy. So to define work done, that is energy consumed from a source EMF, is maintaining the electric current in the electric circuit for a given time, is called electrical energy consumed in the circuit. So now, as it is, we have seen power is equal to work done by time. That work done is nothing but energy per time, and we have already read power is equal to potential difference into I. So now power is equal to work done by time. Now here work done from a source, that is work done, we can write is equal to power into time. See this formula, power is equal to work done is equal to power into time. We have reproduced it. What is power? Power, as it is, power is equal to V into I into time is equal to T, or Vi into T. This is the work done. This work done, because charge is moved from here to here by the EMF, work is done by the battery to move the charge. It means because of the movement of the charge, current is flowing. Current is flowing means heat is dissipated. Heat dissipation. Heat dissipation means heat comes out of the resistance. This heat dissipation is nothing but energy, that is heat energy. How much work is done, that much energy is converted, how much that much work is converted into heat energy. So we can equate work done. Work done is equal to energy. As it is, work done is equal to energy. How much work is done? It is converted into heat energy. So work done is equal to energy by work energy theorem. Therefore, energy VI into T. So energy always in Joule. Always in Joule. So this we can write a different form. Energy is equal to, since V is equal to I into R, or I is equal to V by R by Ohm's law. So energy is equal to V into I into T, or V can be replaced by I into R into I into T is equal to I square R into T, that is energy, which is equal to energy. We can call it sometimes heat energy also, I square R, and in place of I we replace V into I is equal to V by R into T is equal to V square by R into T. Therefore, these are the unit. This is a different types of expression for heat energy dissipated when a current is flowing from this end to this end of the conductor having a resistance of R, and this work is done by the battery in moving the charge from one end to another end, and hence current from one end to another end. So energy dissipated, that is energy, heat energy evolved, that is dissipated in the resistor, is given by V square I square R into T, or V square T divided by R, or VI into T. These are the three expressions. This heat energy is in Joule. Unit of electrical energy. See, in terms of power, we have written power is equal to rate of work done is equal to energy by time, and power is equal to V into I. And unit of power is equal to joules per second, or joule per second is equal to watt, or power is equal to V into, this is volt into ampere. This already we have seen. Now, what is energy? Energy is equal to power. Energy is equal to work done. What is work done? Work done is equal to power into time, that is power is equal to V into I into time. This is an unit. We can say unit of energy. Unit of energy is equal to, this is volt into ampere into time. This is one way of expression. And what is volt into ampere? Volt into ampere is equal to joules per second. Joules per second is equal to watt. So volt into ampere can be written as joule per second into time. Therefore, unit of energy is equal to watt into time. This way also we can express watt into seconds. See, the very important, the power is in watt or joules per second or volt ampere. And energy is nothing but heat energy. How much work is being done? Work is equal to power into time. VI, as it is, we said VI, what is volt ampere into time R. Volt ampere time, the volt ampere time can be written as joules per, because this is equal to joules per second, already we have derived, or this can be written as watt into time. So this is the way how we express, because this will be, sometimes they may give in this unit, sometimes they give in the unit for energy, sometimes they may give volt ampere time. So we must be able to recognize, and we have to remember many of the things, that is work done in moving a charge in an electrical circuit is equal to potential difference. Current is equal to how much charge moving in a given time. From this, and power is equal to volt V into I, and work done is equal to Q into V. Work done is equal to R I square R into T. See, the basic definition is work done from a source is maintaining the work done. So this work done is converted into heat energy in the circuit.